Connie from West Virginia. Well, maybe. I don't know. But what I do know is we've got joke of the day, and I know you're ready for it. So why was there thunder and lightning in the lab? Because the scientists were brainstorming. Okay, let's brainstorm our way, or focus our brains on the principal nth root of a number. Now, the principal nth root of a number is kind of similar to the idea of a square root of a number. You are familiar with the square root of a number. And what that indicates is if b squared is a, then b is the square root of a. In other words, when I'm looking at the square root of this number a right here, I'm asking myself, what would I multiply by itself to create that number that's underneath the radical? And as you saw right here, the number that I multiplied by itself to create that number there that was underneath the radical was the b. Notice the similarities between the square root of a number and the nth root of a number. This says, instead of if b squared is a, if b to the nth power is a, then b, just like this, then b is the nth root of a. So where I had square root of a is going to be this number that I multiplied by itself. In this case, I'm going to say nth root of a is going to be this number that I multiplied by itself that many times. So again, very similar to what is working with the square root is going to happen here. Now, when you have a square root, there is an understood 2 sitting right here. And that is why we just don't show it. Kind of like if you have a variable like an x, and there's a 1 sitting in front of it, you don't show the 1 that's in front. Or say, for instance, if you have a fraction, like perhaps maybe a 4, you don't need to show when it's over a 1, you don't need to show the 1 that's underneath. There's oftentimes things that you just don't have to show. Well, here, whenever there is no number here in what we call the index, then it's understood to be a 2. And that 2 says to me, I want 2 numbers multiplied together. So in other words, that's how we come up with the number times itself, 2 numbers. So it's like saying, when I'm looking at this, I want 2 slots, and I want to multiply them together, and I want the same number in both of those slots. And that's how I get b to be the square root of a. Similar idea is going to happen here. So when I'm looking at the nth root of a, whatever this index says, and again, that's the index, that tells me how many slots I'm going to have. So I'll look at this and I'll say, okay, then what I'm going to do is I'm going to have n number of slots, however many that would be, and we'll just put dot, 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 and I'm going to say there's going to be n number of slots, and I'm going to multiply all of these together, and then what's going to sit inside them is whatever number I would multiply by itself that many times to create the number underneath. All right, let's take a look at some examples, and then it'll kind of settle in with these examples. So I'm going to simplify each one of these, and notice my index of 3. That means that I want 3 slots. I'm going to multiply all these numbers together. I want the same number in each of those slots, so that I multiply that number by itself 3 times to create a 27. What would I multiply by itself 3 times to create a 27? Well, if I would put a 2 in here, 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. Not big enough. Let's try a 3. So 3 times 3 is 9, 9 times 3 is 27. Aha, there it is. So the cube root of 27, or third root of 27, is simply going to be a 3. So now when I look at fourth root of 625, once again the index tells me how many slots. So I've got 1, 2, 3, 4 slots. I'm going to multiply all these numbers together. I want the same number in all the slots. So if I try 2, 2 times 2 is 4, times 2 is 8, times 2 is 16. Nowhere close to being big enough. Now when I try that 3, 3 times 3, now remember we figured out that 3 times 3 times 3 is 27. 27 times 3 is 81. Still not quite big enough. So if I try 4, 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256. Still not quite big enough. Well, let's put a 5 in there and see what happens. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5, yep, it's 625. So the fourth root of 625 is a 5. Now, let's look at the more common nth roots. Some of these show up so much, it's a good idea to have them memorized. And here are the more common ones that it is a good idea to have memorized. So the cube root of 8 would mean I have 3 slots, 1, 2, 3. I want the same number in all 3 slots so that I multiply to get an 8. Well, 2 times 2 is 4. 4 times 2, there it is. There's my 8. So the cube root, the third root of 8 is 2. Now, with the 27, cube root of 27, again, this index means 3 slots. I want the same number in all 3 slots. So if I do 3 times 3, I get 9. 9 times 3 is 27. Okay, so the cube root of 27 is 3. Now with the 64, again, 3 slots because of the index. So let's try 4. 4 times 4 is 16. 16 times 4, yep, 64. So the cube root of 64, or the third root of 64, is just 4. And I bet you can guess what the cube root of 125 is. We seem to be kind of going down the line here. Sure enough, 5 times 5 is 25. 25 times 5 is 125. So the cube root of 125 is 5. Now let's take a look at these fourth roots. In those fourth roots, remember, this index indicates 4 slots. I want the same number in all 4 slots. So let's see if the fourth root of 16 is a 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2, yep, it's 16. So the fourth root of 16 is 2. Now let's try that fourth root of 81. Give 3 a shot. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3, yep, it's 81. So the fourth root of 81 is a 3. And I bet you can figure out where we're going to head with this. Let's try that 4 out. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4, yep, it's 256. So the fourth root of 256 is 4. And now I bet you know what's going to happen with that fourth root of 625. 5 times 5 is 25. 25 times 5 is 125, like we figured out. And 125 times 5, sure enough, is 625. Now, fifth root would indicate how many slots? Yes, 5 slots. I want the same number in all 5 slots. Let's see what happens with the 2. 2 times, now we already figured out that if we multiply 4 2's together, we get a 16. 16 times 2, yep, it's 32. And like I said, these are the more common nth roots, ones that it's a good idea to go ahead and have them memorized because they do show up a lot. So I hope this helps with the concept of an nth root. Like I said, the main thing here is that this index is going to tell you how many slots. You want the same number in each of those slots. You're going to multiply them all together to get the number that's underneath. And so therefore, that number that goes in the slot, that is the nth root of whatever that number is. And like I said, if it doesn't look like there's a number in the index, then it is understood to be a 2, meaning 2 slots, and you want the same number in each. And that's how we arrive at the square root. I hope that helps. Have a great day.